These next two problems concern a confidence interval for a proportion. A soft drink manufacturer purchases cans from an outside vendor. Of a sample of 70 cans, 52 meet the specification for puncture resistance. Find a 95% confidence interval for the proportion of cans that meet the specification. Now you notice that on the screen, of course, I've put down the formulas for this. This is the improved confidence interval that is used for proportions. This is completely different than what is pre-programmed into most calculators as well as pre-programmed into Microsoft Excel. And so what we're about to do now is not what was returned by the calculator or Excel, so we have to have this down here. So all to say, don't become too comfortable with your calculator or with Excel, because if you simply use the pre-programmed function that's in the calculator, you'll get the incorrect answer. We notice that the formula that we derived in class has the same form as the other confidence intervals. There's some centered location, plus or minus a number off the z distribution times something that looks like a standard error. So it has the same superficial look. However, the computation of this is actually going to be a little bit different. You see the formula is considerably more complicated. So in our problem, we have that p hat is the observed proportion of successes. In our case, that is 52 out of 70. And therefore q hat is the observed proportion of failures, and that works out to be 18 over 70. The value of n is, of course, 70. That's the number of trials. And then to get the value of z, for this problem we have a 95% confidence interval. So the area in the middle, it's not, the problem does not say it's one-sided, so by default it's two-sided. The area in the middle is 95%, and that leaves 2.5% in the left tail, and hence 2.5% in the right tail, so that the total area of the left tail plus the center is 97.5%. So the total shaded area here, including the center and the left tail, is 97.5%. So the z value we want here is going to be the 97.5 percentile, and so we use either Excel or else a calculator or else the table to get that number. So we turn it on, and we get that the end norm of 0.975 is equal to 1.95996. So that's our z value, 1.95996. Okay, so now we just turn the crank on the formulas here. So p tilde is going to be the center of the confidence interval. Now this number is going to be different than p hat. It's going to be fairly close, but it'll be different. So 52 over 70. So we just have to type this in and be very careful that we don't mistype something. 52 divided by 70 plus the z value squared divided by 2 times n. So that parentheses closes the denominator, and that parentheses is the top numerator, divided by 1 plus the z value squared divided by 70. And so the number that comes out is going to be the value of p tilde, assuming I type this in correctly, which is about 0.7302, and that is a little bit different than just simply p hat, which is 0.7428. So 0.7302 is going to be the center of the interval. Next, we have to figure out the error, so the margin of error. And that'll be equal to the thing on the left. So once again, let's get the end norm of 0.975 so I can have that in the register. And then we just simply plug in. So the margin of error will be equal to that value of z times square root of p hat 52 over 70 times q hat, which is 18 over 70, all divided by n, plus the answer squared divided by 4 times 70 squared. And let's check the parentheses. So this parentheses is 52 over 70, that parentheses is for that 70, so this parentheses is still left over, and so when I close out this parentheses, that's going to be everything under the square root, divided by 1 plus z squared divided by 70. And so when I hit enter, that's going to be the margin of error, which is 0.1005 about. And so there's my answer, about 0.7302, plus or minus 0.1005. And so that will be the answer to problem number 14, my 95% confidence interval for this proportion. For problem number 15, we have a new question, which is this margin of error is actually quite large, 10%. And it's quite large because we had not a very small, but a relatively small sample size of 70. So how big does the sample size have to be to have a 99% confidence interval that has a margin of error within 0.05? For that, we have a different formula, which I'll now pull up. And here it is. N is equal to z squared times 1 minus w squared over w squared, where w is the width of the confidence interval, and z is, of course, the z value you need. This is a conservative estimate for the value of n, meaning this is kind of the worst case scenario, depending on whatever the actual value of p hat actually is. So let's use the formula. We have that. Well, we have a new value for z. For starters, we have, this time we want a 99% confidence interval. So 99% of the area lies in the middle, which leaves 0.05 in this tail. And so the z value that I need is going to be in norm of 0.995 this time. And so 2.5758. So there's the value of z. And the value of w that I want is actually going to be 0.1. In this formula, w is the width of the confidence interval. So when we set the confidence interval up, there will be some center. We go up by 0.05. Or if we go down by 0.05, that's going to specify the confidence interval, so that the total width of the confidence interval will be the sum of those two things, which is 0.10. So I just want to draw that quick illustration to say why it's 0.10, 0.1. Okay, so now it's just a matter of plugging into the formula and seeing what we get. So popping the calculator out, we have the thing that we just got, squared, times 1 minus 0.1 squared, divided by 0.1 squared, and we get an answer of 656.8. And so always to be safe, we round up to the nearest integer for 657. So the answer for this problem is that n is equal to 657, and that is the number we need to conservatively construct a 99% confidence interval with a margin of error of 0.05.